you agree that your roots are appearing multiple times now? Okay? So here's what we're going to do. The first one is, the only thing that's weird about this is that we have our eyes. Now, we said we would get 3 roots because that's what the degree is. And we truly do have 3 roots, don't we? We have -5, which is our only real root, and we have plus and minus 2i, which we can't graph, correct? Okay? So, graphically, we know 1, 2, 3, 4, -5 is where it crosses the x-axis, and the y-axis, it crosses at 20. And just so we're really clear, some of you are losing points on your graphs because you're not putting correct tick marks along the x-axis. And I need you to do that. Don't just tell me where these numbers are. Go across, and if you've got 5, then I want 5 ticks. Okay? No. Vertically, I'm okay with this for these types of graphs. This is not a line. Would you agree? This is a curve because our highest exponent is not to the first power, which is what a line would look like. So we know that this is a curve whose tails end up in which quadrants? First and third. Body graph this. So we know that it's doing something like that. And that's all you're going to have to do. It only crosses the x-axis in one real number, but it's still a curve with tails in the first and the third. All right, on this one, what we notice is that this 3 is appearing. Now, I want you to notice that it's an odd number of times, because if it appears an even number of times, it's going to do something else on the graph. So if your root appears once, or 3 times, or 5 times, it's always going to behave in the same manner. Okay? We know that it will definitely cross at +3, and I'm going to color that in a different color because something weird is happening here. And it also crosses at -1, and our x-intercept or y-intercept is down here at -27. Now the degree of this polynomial is the 4th degree. And so that tells me that it's positive. And where are your tails supposed to be? Both of them are up, right? Okay. So we know that it's in the first and the second. We know that this isn't a parabola, but the only way that we can get this to have tails in the first and the second is at this root of 3 that appears an odd number of times, that we continue to just pull our graph through that point. Now you'll see why I'm saying pull it through in a second. Okay? Are we okay with that? Are we good? All right. This next one. If you notice, the -3 appears an even number of times. So we have 3 roots. We know that at -1 it crosses, and at -3, which I'm going to do in a different color, it crosses and something weird is happening there. And then our x-intercept or y-intercept is at 9. Now the tails should be where? First and third, correct? Well, it's got to go through this -1 and it has to end up here. It's going to start here. Well, the funny thing about even roots is that you don't pull the graph through that point. You come up to that point, however that tail is supposed to be, and then you bounce it back down and then pull it through the next root. So even roots touch the root, and even a root that occurs an even number of times touches that root and either goes back down if it approaches it from underneath or bounces back up if it's coming down to that value. So that's a bounce. So even number of times you bounce at the root or touch it, just touch it. Whereas if you have an odd number of roots, as in this one, you pull the graph through the root. pull the graph through the root. Doxy?
So with the even number, you're touching it, it's going up and then back down.
No, so I'm coming from underneath. So I'm going to touch that root and come back down to that quadrant. And then go through the next one. If this was the one that was going to bounce and I'm up here, I would come down and go back up. So you got to end up, after you touch or bounce, back into that same quadrant. Okay? All right, so let's look at this last one. Okay, it's another bouncing one. The roots of this one are, let's say we go 1, -2, 8, -13, and 6. Anybody get this one to work?
Yeah.
We start with 1, 1, 1, -1, -1, 7.
You need a 0.
Oh, rats. Get my 0 here. 1, -2, 0, 8, -13, 6. So 1, 1, -1, -1, 7, -6, -6. Great. Okay, then we got to do it again. So my guess would maybe be, I don't remember. Let's try 1 again. 1, 1, 0, 0, -1, -1. Ooh, good, this works. 6, 6, 0. So these are all roots. Okay, we're going to try, let me try 2. 1, 2, 2, 4, 3. It's not working, is it? Let's try -2. One, -2, -2, 4, 3, -6, 0. Woohoo! All right. And at this point, I can use the quadratic formula. X squared minus 2x plus 3 equals 0. Actually, does this factor? Does it? What are your factors of 3 that give me -2? No. So negative b plus or minus the square root of b squared minus 4ac. Because I want real and imaginary roots. Gives me 2 plus and minus, this is square root of 8i, so 2 root 2 with an I on it, which is 1 plus and minus root 2i. You following this? Okay. My goal, though, for you was to graph this. Okay, so these are the imaginary roots, which we cannot graph. Would you agree? The roots that we can graph are at -2, which we're going to highlight in a different color. No, which one appears? The 1. Which one appears an even number of times? The 1. So we're going to use the 1 in a different color. And the -2 is just a normal root. And where are your tails? First and third. Which one is the bounce occurring at? At 1. Which one do we pull through? We're just going to treat this one like normal, right? So we're going to come down from the third. We're going to pull through. What's our y-intercept? Okay, here's 6. We're going to come to 6. We're going to come back down. Now, what am I going to do at this point? And so that means, what do? Go up or down? We have no other zeros to graph. And so our tail ends up in the first quadrant where we said it was supposed to end up. Would you agree? Okay, yes. See how my graph goes actually through? It doesn't touch and go back down. My option is to either go through that root and into the next quadrant or go back down into the quadrant that you were at. Pull it through. Yes. So if your root occurs an odd number of times, you just treat it like a normal root. It's just if it happens an even number of times that you need to treat it differently. Okay? Does that make sense? So you're graphing these now. All we're doing from here on out is graphing it, but we've got some funny things that could happen on the graph. Okay. This is the new part. This is working backwards. I'm going to give you the zeros. You have to give me the polynomial equation. So, first one's easy. If I tell you that my zeros are 3 and negative 2, that means I'm telling you that x equals 3 and x equals negative 2. Does that make sense? If I need a polynomial expression, I need it in factored form. So let's work backwards. What would my factors be if x equals 2 and 3 and x equals negative 2? X minus 3 and x plus 2. How do I create a polynomial out of that? Foil it. Exactly. So now we foil, and we get x squared minus x minus 6 equals f of x. That's my function whose roots are 3 and negative 2. Pretty straightforward. Okay, so let's mix it up a little. What makes this next problem different? The i's have it. All right, x equals 2, x equals 3i, but we don't ever get just 3i. We always get them in pairs. What's this poor guy's pair? Negative 3i. This is the one that you need to realize is missing. If I give you positive 3i, then the negative 3i, because remember we got it by taking the square root, which gives us positive and negative values. So in factored form, that leaves me with x minus 2, x minus 3i, and guess what the last one is? X plus 3i. Now, which two do you want to multiply out first? Why would you want to do the last two? And they are called conjugates. And with conjugates, what always drops out? Middle term. So we know that we get x squared. The middle terms are going to drop out. So I'm just going to drop right away to negative 3i times positive 3i, which is 9i squared. But that's really x squared plus 9. Yeah? So then we multiply by the x minus 2 still, right? And we're foiling again. X cubed minus 2x squared plus 9x minus 18 is my f of x. Okay? Let's look at this last one. Which one's going to have a conjugate? That's not saying square root of 5. It's 2 plus square roots of 5. So x equals 1, x equals 3, x equals 2 plus root 5, and so its conjugate is x equals 2 minus root 5. That gives me in factored form x minus 2, x minus 3. Okay, this becomes a mess. This is going to say x what? Oh, thank you. That is x minus 1. So when I write the conjugate for this plus 2 plus root 5, and I'm taking everything to the left now, right? So the 2 changes sign and the root 5 changes signs, correct? So it's going to be minus 2 minus root 5, correct? And the other one's going to be x what? Minus 2 plus root 5. Now these are conjugates, the last two, right? Okay, so we're going to multiply these out together. What's x times x? Okay, you might want to do this kind of the longer way and take x times each of these 3 terms. And so it's going to be x times negative 2, and x times root 5. And then we're going to go to the 2. And we're going to distribute that, and we're going to layer. Remember how I taught you how to layer? And so we're going to take negative 2 times x and get negative 2x. Negative 2 times negative 2 is? I'm going to put this over here because I don't have a place to layer it under. Negative 2 times root 5 is? Negative 2 root 5. Now, all of these funny things with roots are going to disappear if you've got your signs right. Okay? So now we move to the negative root 5. Negative root 5 times x is positive root 5. See how it's going to get eliminated? Oh, yeah, sorry. And then negative root 5 times negative 2 is positive 2 root 5. And then what's negative root times positive root 5? Negative 5, which we'll put under the 4. X squared minus 4x. This drops out, minus 1. Guess what we have to still do? Why would we factor? We got to multiply these two together. This is going to be x squared minus 4x plus 3. I think I gave you 1. Okay? And then we get to do what? FOIL some more. I need a polynomial. So x to the 4th minus 4x cubed minus x squared. Then I'm going to distribute the negative 4x. And I'm going to get minus 4x cubed plus 16x squared plus 4x. And then I'm going to distribute the 3. 3x squared minus 12x minus 3. And my final answer is x to the 4th minus 8x cubed. This is plus 18x squared minus 8x minus 3 is what f of x equals. So anytime you have a conjugate, multiply those conjugates together first to eliminate anything funny. The square roots and the i's.